Hello guys, this is Prime Concept. You're welcome once again to my channel. You are a returning subscriber, you're highly welcome. This is your first time of meeting me, you're welcome to my channel. In this channel, we'll learn a lot of concepts of mathematics, physics, chemistry. So we deal on sciences. So very importantly, in this video, we're considering set theory, which we've introduced already. So we want to consider the concept of complement of a set. We've looked at series of algebra in sets. We've talked about union of sets, talked about intersection of sets. We want to consider in this video the complement of a set. Now, we are going to mention that there are two types of complement. It will help us understand them separately. So let us mention that there are two types. We have two types of complement. So number one is what we call the absolute complement. Sometimes the absolute complement can be called universal complement. Now, what is the absolute complement? This is the complement of a set with respect to the universal set. So that is what we call the absolute complement. It is complement with respect, or relative with respect to the universal set. That is what we call the absolute complement. So it has to do with one set and then the universal set. So very importantly, what is the universal set? The universal set is a set that contains all the elements that can be found in every other set. That is the universal set. The set that contains all elements that can be found or not even found in other sets is known as the universal set. The universal set is usually denoted with this symbol. We usually use this symbol to denote universal set. Right? Now, when we talk about the absolute complement of one set with respect to the universal set, simply means those elements that can be found in the universal set that are not present in that set. That is called absolute complement. The absolute complement of a set are the elements that are found in the universal set but are not found in the set itself. Now, say for example, we want to talk about the absolute complement of a set A. It will be denoted by this with a prime. So this means complement. I'll be calling it complement for short, right? But then you should notice that it is absolute complement we are referring to. Complement with respect to the universal set. This is the symbol for it, A prime, right? Yes, so this is called the absolute complement. So this is called absolute complement. Now let's give a quick example. Given a universal set that contains elements 1, 2, 3, 4, 5. So these are universal sets. And we have a set A that has elements, let's say 1, 3, and 5. So this is our set A. So if we want to find the absolute complement of set A, which is this. So what it would mean is we want to remove A from the universal set. So you want to remove A from the universal set. So this can still be written like this. You are removing A from the universal set. So it's still the same thing. So what will be left in the universal set becomes the answer. So what can I find in the universal set that I cannot find in A? You will see that what is not present in A but is present in the universal set is going to be 2. And then what else? We have 4. So it means that the complement of A, the absolute complement, is what? A set containing elements 2 and 4. Which is still written this way. You can call it universal set difference A. So you can still call it that way. Universal set difference A simply means that you cancel out what you have in A in the universal set, then what is left in the universal set is your answer. So that is what it means. Let me give you one more example to buttress the point. Now say we have So we have the universal set this way. So we have our universal set this. We have A, B, C, D. So we have this as our universal set. Then we have set A to be A and D. This is our set A. I want to find A complement. We want to find A complement. So I've told you that A complement simply means universal set difference A. So this is called universal set difference what? A. So you're going to cancel what you have in A from the universal set. So if this should go, this should go. What is left in the universal set? What I have left in the universal set is simply B comma C. So this is what we are still saying. So what is present in the universal but is not present in A is what you refer to as A complement. So this is the first type of complement that we have. Number two we want to consider. Remember we said there are two types of complement, which is very important for you to know for the sake of your exams like your IGCSE exam, your SAT exam, your JAMB exam is commonly asked, your WAEC exams, and so on, your 100 level university exams, your high school exams. Now, the second type of complement is what we know as relative complement. Relative complement. So what is relative complement? Relative complement is the complement of one set with respect to another set. So it is the complement. It is the complement of one set with respect to another set. So this is a complement that compares two sets. Unlike the previous one that compares a set and the universal set, the relative complement compares two sets. So let's see how it works. Of course, the relative complement is actually denoted by this. Say we have two sets, given set A and B, then the complement of A with respect to B is given as. So if you have two sets and you want to find the complement of A with respect to B, this is how we write it. A complement of A with respect to B is denoted like this, or we denote it this way, A difference B. So is either we use this symbol or we use this symbol. Both of them are saying the same thing. So this means A difference B. A difference what? B. That is what it means. So how do we find it? Very simple. Let's take an example. Say we have A is a set of 1, 2, 3, and 4. Then we'll have that B is another set of 1, 3, and 4. Right? Now we want to find number one, we want to find A difference B. Then number two, we want to find B difference A. Let's see if both of them would be the same. So first of all, let's start with A difference B. A difference B is going to be, how do we find A difference B? It simply means subtract B from A. What is left in A is your answer. Subtract B, remove B from A. What is left in A is your answer. So let's see. I'll remove 1. I'll remove 1 from A. I'll remove 3 from A. I'll remove 4 from A. What is left in A is just what? 2. So I have 2. So my answer for A difference B is what? Is a set that contains the element what? 2. Right? Now let's see the other way around. Let's see B difference A. B difference A simply means remove A from B. What is left in B is your answer. So let's see. This time we're removing A from B. So I'll remove 1 from this. I'll remove 3 from this. I'll remove 4 from this. What is left in B? You'll notice that there is nothing left in B. So meaning that B difference A is what? Is an empty set, because there will be nothing left. When you remove 1, you remove 3, you remove 4, nothing is left for B. So it means that B difference A is an empty set, while A difference B is a single thing. So you can see that they are not equal. This quickly brings us to a point to note about this, about relative complement. The things I want you to note is that A difference B is not equal to B difference what? A. So this actually means that complement, relative complement, is not symmetric. Relative complement is not what? Symmetric. Relative complement is not symmetric. So assuming A difference B is equal to B difference A, then we would say that relative complement is what? Symmetric in A and B. So, but it is not symmetric because we can clearly see that they are not equal. Now there is something called symmetric difference, the difference that is symmetric, unlike relative difference, which is not symmetric. So we have what we know as symmetric difference. So that would be our next point, symmetric difference of a set. Symmetric difference. Now what is symmetric difference? Symmetric difference of a set is actually denoted by the symbol delta. So this is the symbol for symmetric difference. So, and it is given. So say A symmetric difference B is given by the relation A difference B union B difference what? A. So this is how we can find symmetric difference. What it means is that A difference B is the same as B difference A. So this is set. So that is why we say it is what? A symmetric difference. If this gives us same result as this, then the answer would be what? Then it means that it is symmetric. So we're going to see an example. We're going to see an example. Also, we have another formula we can use for this. Another formula, in case you don't like this, is that A symmetric difference B is given by the formula A union B difference A intersect B. So this is also true to give us same result as this. Now let's see an example and use the two formulas to solve it. So example, say A is equal to 1, 2, 3. Say B is a set 2 and 3. Okay, let's say 2, 3, 4. Now, question is find A difference, A symmetric difference B. So we want to find this very quickly. Now we would notice that using this formula, let's use this first formula. So using this formula to solve this, I need to find A difference B. So let's find A difference B. A difference B means remove B from A. What is left in A is your answer. So I'm removing 2 from this. I'm removing 3 from this. What is left in A is 1. So this is going to give me 1. And the next thing is to find B difference A. So B difference A is going to be removing A from B. What is left in B? So I will remove 2. I will remove 3. What is left in B is a set containing only what? 4. Then the next thing is to unite them. This is union. So it means this union, this. So A symmetric difference B is going to be the union. So union simply means combining their elements. So I'll have 1 and 4. So this is my answer. So A symmetric difference B is a set that contains the elements what? 1 and what? 4. So now let's quickly use this other formula to see if we get same result as this. So let's see. So we want to use this formula. So it means for me to use this formula, I need to first find A union B. So A union B is going to be a set that combines the elements of A and B. So the elements would be 1, 2, 3, and 4. So this is A union B. Then also I need to find A intersection B. Is a set that contains the common elements in A and B. What do you have in common for A and B? You have 2, you have 2, you have 3, you have 3. So the intersection is 2, 3. So my symmetric difference now is going to be me subtracting the intersection from the union. So let's see. If I remove 2, if I remove 3, I'll be left with just 1 and what? 4. So I'll be left with 1, 4. So are both answers the same? Of course, yes, they are both the same. So this is how we can find symmetric what? Difference. So I believe that the concept of complement can never be confusing to you anymore. So if you have enjoyed this video and you are yet to subscribe, please do well to hit the subscribe button. Drop a like for this video even before you come out. Just drop a like, drop a comment. Tell me the next topic you would want to learn in maths, in physics, or in chemistry. And I'll make sure I create a video on that. Thanks for watching and supporting Prime Concept. See you in my next video. Thank you.